So this is an advanced ISE session, and the expectation is that most of you guys have worked on ISE or have enough experience on ISE so we can start talking about advanced topics, right? A quick introduction on me. My name is Imran Bashir. I'm a technical marketing engineer within Cisco. What that means is that I work inside the business unit. So we kind of play an active role in terms of working with the product, taking your feedback, doing deployments, and doing a lot of stuff, right? So that's about me. I have been with Cisco for about 8 years, and my main focus is on security and more towards the endpoint security and towards the NAC and all that stuff, right? So a quick show of hands. How many do you think you have deployed ISE? Very good. I have the right audience. I think that answers me. So we'll just take that pace and try to hit all the topics. Quick introduction of the session abstract, but I don't want to read all of this stuff. We'll be focusing on 4 main things. We'll start with the right ISE design. What are the things you have to consider for ISE design? Then we'll get into scalability. So we'll talk about not just scaling basic ISE services, but we'll take it service by service. For example, I'm going to take you through guest, through posture, through other stuff, and we'll talk about how can we scale these services and provide a big, flat network that we can. The third thing I want to touch about will be high availability, right? So we'll talk about how can you make ISE more available. And this is not just about adding another node and providing high availability, but we'll get into talking about network side, switching side, wireless side, and we'll cover all of those areas that can provide you high availability on the ISE side. The last thing I'll touch upon today would be monitoring. So once your network is good, up and running, you got the scale figured out, and you have the high availability running in the right way, then we'll talk about how can we monitor your ISE network for optimal performance, right? So let's get started. Obviously, I wouldn't have time to cover everything in ISE. You are in 3432, which is the advanced ISE session, but there's so many other sessions that talk about ISE, right? Not just the sessions, you also have labs that you can take and learn more as you go along, right? So my presentation should be uploaded, and feel free to download it, and if you want to follow that, we'll do that, right? Okay. Typically, my sessions are very interactive. I do like getting questions, taking questions, and answering them. Obviously, it's not a point-based system, but you have opportunity to get some stuff. For example, I have a few things that I like to give out to make it more interactive, and some other good stuff as well. Let's keep it interactive. All right. As I said, the whole slide deck is about 500 plus slides. We're not going to talk or share 500 slides today, but we'll be touching all the main topics that we can. But the way this session is built out over the years is that we keep on adding more stuff to it. And as the stuff gets more absorbed into the field, we try to hide that content, but we don't want to take it out of the slide deck. Because a lot of our partners, our customers are actually using this content to do more design work for end-to-end ISE. Because it talks about a lot more number, a lot more scales, and so many other things that are very, very useful, right? So just as a reference point. Okay. We do have Cisco WebEx team. I do have my esteemed colleague in the room that will help you answer any questions. But you feel like, hey, take my question in the room, I'm more than happy to do that, right? We have a mic, but if you don't feel like standing up, I can repeat the question as well, and we can go along like that. All right. Have you guys heard about the community site we have within ISE? Very useful resource. There's a lot of TMEs, a lot of field people, a lot of partners, a lot of you people who help us answer these questions. So if you haven't visited these sites, I would highly recommend to take a look at that, and you can get a lot of answers on that site. We do update it continuously. For example, any new content that comes out, these web pages will be updated with all the new content, right? So make a note of that, a good site to visit. So let's talk about agenda. We'll be starting with design, and I'm going to take you through sizing, deployments, and nodes, right? We will be talking about some of the new platforms that are coming out, but obviously we don't have all the scale numbers because they're not out yet, so it'll be more of a high-level talk about those platforms, and then we'll see how that works. After that, we'll get into bandwidth and latency, right? If you have a latency issue in your network and you have ISE globally deployed across many, many countries. What do you do about that? What are the options you have to change or leverage this bandwidth and latency and still make the ISE network work? The next thing we'll get into scaling ISE services. As I said, this will be not just basic ISE services. We'll take it one step at a time, Radius, LDAP, Passive ID, guess all the services of ISE, and we'll talk about how can you scale these services one by one as you go through the network, right? Now, the last topic would be high availability monitoring. These are fun topics. So we'll spend a lot of time talking about flows. When the packet comes in from a switch, it goes to the ISE, then it gets redirected through a load balancer. What happens, right? In all different scenarios. So I'll take you through all those scenarios to make it more interesting. And obviously, it's a lot of content. In my sessions, typically, I don't want you to sleep, but stay awake, and then we'll just go around that. To track us where we are in the session, because there's a lot of things we're going to do, we'll be following this map. For example, the first one is ISE design, so I'm going to take you through sizing, deployment, platforms, and bandwidth, right? Then we jump on to the next step, which is scaling. But these are the multiple things we'll talk about today, right? I may skip some topics depending on time or if they have been presented in the past, but the goal is to cover as much as possible and talk about the new content we have from last session to this session, right? So we'll keep an eye on that. All right, let's get started. First of all, ISE deployment. A quick overview, and I typically blaze through these slides because this is well known in the field. But within ISE, we have 4 personas. We got something called PSN, or I'm going to start with Policy Services Node, which is really the workhorse of ISE. So all the authentication, all the profiling, all the guest work is done by the PSN node. And that is where we talk about where should I place my PSN node. If I have a distributed deployment with many, many locations, should I place it at a branch or should I put it in a data center and work through that? So we'll cover all those scenarios. The next persona that we will talk about is Policy Administration Node. Now, this is the node where you log in into ISE and you start configuring stuff. So whatever you configure into PAN, that gets pushed across the deployment in all of the nodes. Now, one thing that I typically get is that, hey, does PAN have a database, right? It does. So over the years, what we've done is that our PAN also holds a local database. That's why the requirement that you see, hey, you need to have a 200 gig hard drive, is recommended to have from 200 to up to 300, which is the most recommended in ISE 2.4. We'll talk about those topics as well. The third one is monitoring and troubleshooting. Nothing fancy here. This is the node that collects all the logs from the network. Any reporting that comes in, it's all collected at the monitoring node, right? So really, we have to really think about how can we plan the placement of monitoring node because all the replication of database and everything depends on this node. That's why typically this is the node that has the highest power in terms of all the platforms you have and the larger disk space, depending how much amount you want to save in the network. The last one is PX Grid, which talks about really connecting ISE with other resources on the network. For example, ISE talking with StealthWatch, ISE talking with Splunk, and all these use cases that are done through PX Grid, which is the platform exchange grid. So there are 2 ways you can scale ISE. You can have ISE in a single node, and that can go all the way up to 20,000 concurrent endpoints as of today with ISE 2.4 and 35 XX platforms. And then we also have the multi-node ISE deployment. That is where you can scale ISE to about 500,000 active sessions on the network, right? Anybody knows how many endpoints can we have in ISE? How many maximum endpoints? 1.5 million. That's the maximum endpoint you can have in ISE. So, really quick update on 36XX platform. These are the new big boys that are coming out very, very soon, and they will support much larger numbers, right? We're not going to talk about numbers today because we're still testing them as going out. But my point is that I really wanted to update you guys that there's a new platform that is coming out in the market. For example, if you're just ready to push a button and buy an appliance, something to know that 36XX platform is coming out as well. And at the same time, ISE 2.6 will come out as well, right? So you might say, hey, what happened to ISE 2.5? The working code today is ISE 2.4. There will be no ISE 2.5, but there will be ISE 2.6. That's the release going to come out with these platforms.
When is the expected time?
Again, I cannot give you a timeline, but we're very close. We're very close, yeah. And we're just testing the final numbers, but yeah. All right, so a quick update. That's what we have in these platforms. But look at these platforms. Like on the high-end platform, we're talking about 256 gig RAM loaded into the box, right? And the CPU, that's pretty high. For example, talking about 12 cores of CPU in this box. So these are really, really powerful boxes. And our goal is to really scale ICE to more than 500,000, and we'll see how that works out, right? Okay, so for your reference. So let's talk about how these nodes talk to each other, the end-to-end flow. Because later when we get into more details about flowing packets through load balancers and all that stuff, I think this slide is useful. So what happens is that when a user, when an admin logs into ICE, they log into the PAN node, and that is where they can configure ICE. The moment you configure ICE, it pushes all the policies to the PSN node, right? Next thing, when a user connects to the device is programmed to go talk to the AAA server, and that AAA server is the PSN IP address. If you have a load balancer, you're going to put the load balancer IP address, and all the PSNs would be behind that load balancer. After that, depending on if you're connected to the Active Directory or LDAP or any identity store, your request will be checked against that ID store, and depending on success or failure, you will be authenticated to the network. And to close it off, all the syslog will be sent to the MNT node. And if there's any session that needs to be published outside of ICE, they are published through the pxgrid node, right? Very, very simple flow ICE. These are the platforms we have today. We're talking about 3415, which can do 5,000 active sessions of the network. And our biggest box, 3595, can do 20,000 active sessions on the network, right? Now, again, just to reiterate, when we say 20,000, this means 20,000 users or endpoints on the network at the same time, right? But you can have up to 1.5 million users loaded onto ICE. But at a time, we're talking about 20,000 in a standard mode. Yes, sir? So the question was which version of ICE that is?
How does it scale to virtual appliances?
Okay, very good question. Yeah, so the question was how does it scale to the VMs or virtual appliances? I'm going to cover that. I have a slide on that, yeah. But the short answer is that as long as the numbers are matching, you're going to get the same performance, right? Let's talk about basic two-node deployment. That's the next recommended deployment we tell to our customers and partners is that when you go into production, you got to have HA or high availability. So let's start using 2 boxes of ICE instead of 1 box, right? But the thing to note is that the total number of endpoint is still 20,000, even with 2 boxes. But this is giving you high availability on the network. So as you move along, the third option that we give to our customers is, yes, if you have multiple branches, you can have up to 5 PSNs, which can get out of the single deployment, and that's a one step forward to your distributed deployment. So now we're talking about, hey, I have multiple branches, I probably have multiple data center, and then I do want a PSN where my users can connect directly, which is close to my endpoints. So in that case, the next step forward is, yes, let's do a basic distributed deployment, and I can give you up to 5 PSN outside of ICE. The last one is that if you have all the nodes running on different personas, then you can have up to 500,000 active users on the network, right? So yes, that's the fully distributed deployment that we talk about, but all the nodes are running on different servers or different VMs or different personas. One thing I'd like to add is that it doesn't matter if you're running a platform or a VM, as long as the specs are matching, you're going to get the same performance. It doesn't matter if it's a mix of both. For example, some of the boxes are VMs, some of the boxes are hardware. It's going to be the same performance. All the numbers are still the same. So next thing is that I want to get into design, right? To set ICE, you have to have the right design. And these are some examples of real-world bad designs, right? What's wrong with this picture? This is the escape path in case of fire. And once you land over here, you can be rare, medium, or well done, right? That's the only option you have. So again, design is really, really important, right? There's one other design, and I don't know what was the use case behind it, but yeah, that looks like a bad design as well, right? I'm still trying to figure the use case, but yeah, that's one thing. So with that, I see all kind of design issues in the field. When I go talk to customers, when I'm getting on these calls, they're like, yeah, that's how I've configured my ISE. Like, no, that's the wrong design, right? So let's take a few examples. I have my basic standalone appliance of ISE, as we talked about, and it's running all the services. I've got my PAN, my MNT, my PSN, my PX script, right? Now, what I want to do is that I want to add another node, and that gives me HA. So far, so good, right? Now, what's going on is that I come up with a branch office. I have a branch office. We have users connecting to the network. And I feel like I should be putting a PSN because that's closer to my users. So I'm going to go and stick a PSN over there, right? Anything wrong with this picture? OK. So basically, we talked about the moment you want to add the third PSN, you have to take it out of PAN and MNT, right? So what you have to do is that take these PSN out of the standalone deployment, and you got to make it distributed deployment. So they have to be running in their own personas, right? And I've seen multiple times that people would have a standalone with a third PSN. It's like, hey, it worked for last month. I don't know what happened right now, right? So that could be a bad design example. Let's take another example. So this is my network, data center A. I've got my PSN figured out, and it looks all good, right? Now, I'm going to buy another data center, which is data center B. I'm going to move some of my nodes to data center B, right? So essentially, now I have 4 PSNs running in my network, and everything is good. Now, as the time goes on, I'm going to add more PSNs to the network. I'm going to add the 5th PSN, then I'll add the 6th PSN. What's wrong with this picture? Yes. We're going to get some prices, man. I'm not going to take these home. There you go. There you go. And there was one over here. Exactly. You cannot have more than 5 PSNs. Who said 5 PSN? OK, it's a grab. So what you have to do is that you got to take that PSN out. You got to take the PAN and MNT out of their own deployments, and you have to make them their own servers like this, right? So just to back off, it's one server right now. I'm going to break it into 3 servers. Or you can still leave the PX grid node, doesn't matter. And then you can start adding more PSNs as you go through. All right, awesome, very good. So we talked about design. Next thing I want to touch about is sizing and deployments. So now I talk about what are the real numbers? How many users can I connect? What are the exact radius numbers and things like that? So let's get into that. Again, quick overview. These are different kinds of deployments. You can call them standalone or hybrid or dedicated. What I want to point out over here is that these are the number of PSNs you can have. So in this example, you could have 5 PSNs with 2 PX grid nodes, if you'd like, right? Similarly, when it's dedicated, you could have up to 50 PSNs with, again, 2 PX grid node as you like, right? So that's how you're going to scale. For example, standalone, it's 1 personas. Hybrid, you got a PSN out of the main box, and dedicated, you've got all the PSNs out of the box, right? Again, max number of endpoints is 1.5 million today, but we will be announcing some new numbers pretty soon, right? What's missing from this picture? Remember I talked about 34XX and 35XX? I don't have 34XX here because 34XX platform is not supported by ISE 2.4, right? So if you're running ISE 2.4, which is our latest code, what's supported today is 3515 and 3595, right? OK. Let's talk about hardware and VMs. These are the appliance specs that we have, and the VMs would match to these specifications, right? So take a note of the number of cores, the number of CPUs, and I'm going to talk about a few things as we move along. But within 3515, in this example, I can have up to 6 cores of CPU, and that's with a 16 gig of RAM and 600 gig of hard drive, and that can start giving me some standalone deployments to start with, right? To answer your question, that's how we map the VMs. We look at the numbers, and based on the numbers that are configured by the VM, I'm going to start naming these VMs, right? So a little bit of history here. The earlier versions we have, we call them the IBM platforms, which were like 33XX platforms. Have anybody worked with 33XX platform? Nobody, all right. So the next version that came out was 34XX platform, So if you go to your VM and you try to look at the configuration, the 34 would say UCS small and UCS large, right? And when we get to 3515, we finally figured it out, and now we're calling it 3515 with, and 3595, right? That's what we do. So take a note of this UCS small and 3515 name, because there was a bug we had in our OVAs, and it did get fixed, but I do want to talk about that. There's another VM that we released with ISE 2.4. It's called the Super MNT. So what we did is that we took the large appliance that we had, which is 3595, and we souped it up with more memory. Because what we figured out is that with more memory, we can pin more things into the memory instead of going to the I/O, and that's why the performance was super fast, right? So if you look at reporting and all that stuff with Super MNT, you get really, really good performance. I'm going to talk about that as well. Okay, so this is the issue we had. If you look at, first of all, what happened here? Sorry. Yeah, so everybody knows about hyperthreading. What is hyperthreading? Basically, with hyperthreading, you get double the CPU cores. That's how the platform is recognized. So what happened is that when we released these OVAs for 3515 and 3595, we didn't take into account for hyperthreading. So if you look at these numbers, right, look at this number. It says for 3515, it should be 12 CPUs, which means hyperthreading is enabled. But when you release the OVA, we had 6 and 8, so half of these, right? And that's why the performance numbers were going pretty low, and we had some issues with that. So yes, this did get fixed. This is the bug ID we had. And just to show you the update, if you go now on cisco.com with the new image we put out, basically this is sometime like in December, and all these new OVAs have the right configurations for CPU, RAM, and everything. So you'll be getting the right performance, right? So you're probably going to ask that, how do I know what I'm running now? For example, if I installed my OVA 6 months ago, can I go and check before just starting upgrading them? Yes, you can absolutely go and check. So the way you check it is that go to your ISE node, do a show tech begin platform properties, and then if this says UCS small, which means the CPU numbers are matching to the 34XX appliances, right? And in some cases, people were also getting issues with licensing. That, hey, I think I paid for a 35, but now I'm running 34. That's a licensing issue, right? So all these bugs are sorted out, but if you have an active deployment, I did want to show you these details that how can you go and figure this out on your own platform, that how does it look like, right? So again, for your reference, your 3515 should be 12. That's why it's matching the wrong number. Yes, sir. Is UCS large compatible with ISE 2.4? So when you say UCS large, you're talking about the 34 appliance, right?
Yeah, but the VM equivalent.
Yeah. So just going back to this slide, right here, UCS large is a 34XX. 34XX is not supported by ISE 2.4.
So even for the VMs, we need to stop them, we need to upgrade.
Exactly, exactly. Yeah. And I'm going to talk about these practices as well. For example, if you have a VM with the wrong setting, what can you change, right? So we'll cover that as well. All right. Okay. So let's talk about hard disk number. Pretty much, if you're running a standalone deployment, you should be okay with the 200 gig hard drive, which is fine. Typically, all the PSNs and PAN nodes, they're okay with 200 to 300 gig hard drive space. For PAN, we recommend up to 300 because PAN can also store some of the database that we introduced in ISE 2.1 and 2.2, which is called context visibility. So right on the dashboard, you can see a lot of stuff, right? That's why with PAN, our new recommendation is about 300 gig hard drive. Right? But the biggest recommendation over here would be for your MNT. And I really recommend all my customers to at least have 600 GB for MNT nodes. And that gives you a good performance, that gives you enough logging evidence, and all that stuff that you need to operate a live network, right? So again, simple rule for all the other nodes except MNT, you can have up to 200 to 300, but for MNT, I would recommend 600 gig hard drive on that node. So the question would be, hey, when I started ISE, I had a 200 gig configured on my hard drive, right? can I go and actually change it? So if you simply go to your VM and you increase more memory on that VM, for example, from 200, I'm going to add 400 gig and see what happens. Yes, you might see it in the VM configuration, but this will be not used by ISE. Because hard drive is the only thing that if you add more hard drive space after ISE is installed, it does not get accounted for, right? So even if you're adding memory, you probably have to go and reinstall and then do backup and restore and get it done right that way. Any questions here? All good? Clear? Good. Yes.
What about CPU? Can we change that after or CPU?
Yep. So the question is that, hey, can I add more CPU to my boxes, right? So typically, the CPU settings are not off, but if you're talking about, hey, you gave me the wrong VM and just want to bump the CPU, that should be okay.
Yes, that's what I meant.
That should be okay, yeah. All right, good. So the last thing I want to talk about is that when we look at data purging and all these things, you can actually go to your ISE page and you can see how much it is used, right? I keep talking about 600 gig, but is there a way to track it? You can absolutely go to this page and you can see how much is it used for Radius and TACACS. One addition we did is that since 2.2, now you can actually go and see how much, it's a combined space, and you can pretty much say that Radius is using X% and TACACS is using Y%. We used to have a hard block on Radius as well as TACACS, and we figured out that's not the optimal performance. For example, if you're not really running TACACS or your TACACS traffic is low, then you might get more room for your Radius to grow in your logging space, right? So typically, that's the rule I would follow, and that's how it works. Next thing would be backup and restore through the VM. And I get this question a lot. So snapshot is not a good way to back up and restore ISE. Maybe it's a good way to test something in your lab and stuff like that, but typically snapshot is not the recommended way to back up or save ISE configuration. vMotion is supported, but not really QA tested, right? So we have seen, at least I've seen some issues with vMotion. So typically try to avoid it, but if you're using vMotion and you have a scenario, then I would love to hear about that, and then probably after the session, and I can go over that, what works, what doesn't work. Last thing that I typically get is thick and thin provisioning, right? So for all the ISE installs, yes, you can work with thin provisioning. It's kind of supported, but in production, you get the best optimal performance with thick provisioning because you have the dedicated resources all the time with ISE, right? Think about it. It's a platform that runs on Radius, so it's interacting or working with the users. Typically in the morning, everybody wants to authenticate on your network. At that time, the performance could be the highest peak, right? So if you try to contain that with thin provisioning and you're not giving it enough to grow with your authentication request, you might get some performance hits, right? That's why our recommendation is use thick provisioning instead of thin provisioning, especially for PAN and MNT, because that is where all the databases are. PSN is fine. PSN doesn't have a lot of local database. Maybe Regis database, that's pretty much it, and that should be okay if you're running thin provisioning on the PSNs. All right, so the next thing would be reservations, right? So our OVAs that we're shipping now, they're all pretty much built with the reservations that we want. And then we try not to encourage oversubscription into these reservations, and just keep an eye on it. It's just like that. If you're driving a car for mileage, yes, on a highway it will give you better mileage, but on the road, when the traffic is high, the mileage might vary, right? That's why we don't really recommend or encourage having oversubscriptions for all these ISE nodes, right? But how does it work? I mean, eventually, when you have this pretty much deal with your server team for reservations, right? That's why I really want to spend some time on the hardware. Why do we need all this space? Why do we need the disk size and CPUs and everything? So when you go talk to your server guys, you have enough arguments to talk about that, right? All right, so one other thing I want to talk about is validation. What we added in ISE now is that even before you install ISE, we can check for you. Do you have the right CPU? Do you have the right hard disk and all that stuff, right? So the way you do is that when you're installing ISE, just select option 3 or 4 of system utilities, and that is where you can click on the VM resource check. Once you click on it, it goes and checks for everything out, in your VM or the server, and it can exactly tell you if it's supported or if it's not supported. For example, in this case, I'm getting an error. The installer requires at least 4 GB RAM, and you don't have 4 GB RAM, right? So it'll print out those issues even before you get to install time. Some more stuff, for example, unsupported VM configuration, right? Because it requires 2 more CPU, stuff like that. Right? Okay, Super MNT. So what you notice is that we have 2 appliances, 3515 and 3595, right? And we wanted to add another appliance with more horsepower. Now, we cannot call it large because you already have a large appliance. That can create so much confusion in your network, right? So that's why what we did is that we took the large appliance, we're still going to call it large or something like that, but we're going to call it Super MNT and add more RAM to it, right? So, for example, if you've ever been to US and you try to grab a soda, yeah, they have small, medium, and large, but I don't know if you have seen this guy here, extreme cold, right? So not kind of big stuff. So that is where you have more RAMs, and it can give you a lot more performance, right? So let me show you some of the numbers of Super MNT. Again, it's a 3595 specifications with 256 gig RAM, and that's about it, right? But the performance that you get is exceptional with 256 RAM. Is anybody running Super MNT in their deployment? Okay, good. This was supposed to be musical. Let's go back. All right. All right, so the idea was here is that when you're trying to load ISE and you're trying to run reports on ISE, you can see that the performance is really, really slow, right, in some cases. And that's the problem we are solving with Super MNT. So when you have Super MNT with 256 gig of RAM, you can really get snappy output. For example, you click on a report, you get a report really, really fast, right? So you don't end up opening those 20 tabs on ISE and just work through that, right? Okay. A few other things I want to talk about is that with Super MNT, yes, you can get faster live log. It's very, very fast, easy to work with ISE. You can get faster reports and more export performance, so it's easy to export all the reports. And then there's a major data reduction. For example, we just removed the whole blob data from 7 days and beyond 2.3%. So it gives you a lot more disk space that you work with, and it pins a lot of stuff into the memory. That's why the performance is very, very fast.
One question, is there a way to add more memory to the large appliance?
So if I heard the question right, is there a way to add memory to the large appliance? You mean the hardware server? Honestly, we don't support that. That's why if you're looking for a Super MNT, what's recommended is go with a VM with 256 RAM. That's tested and that's supported. Yeah. Good, thank you. All right, let's talk about bandwidth latency. So in this section, we'll go over if you have a distributed ISE deployment, how can you really define the right bandwidth needs that you have, right? So this is the typical deployment we see within a lot of customers. And what I'm showing here is that you have your multiple data centers, multiple globes. So you have PSNs across globe, right? And the maximum latency that we have, pretty much the way this works is that your PAN nodes will go talk to the PSN to send all the configuration out, just like we said. And then the PSN can also come back and talk to MNT, or in some cases to PAN. For example, if a user authenticated on the network, it needs to come back and update ISE with all those details, right? So what are we talking about? What is the latency requirement over here? So typically, the numbers that we have is between 300 milliseconds starting with ISE 2.1, right? So these are the support numbers. The maximum round-trip latency between 2 ISE nodes should not be more than 300 milliseconds. If it's more, then you could run into some issues, right? Now, I do tell a lot of my customers that, yes, 300 seconds is something that we put out, but I work with customers and they have a latency of 400 or 450. It still works for them. So depending on the use case. So it's not about being really hard on these numbers, but really depending on the use case, what can we give out? Now, from our standpoint, what we have tested fully is 300 millisecond. So in the field, you might say, hey, I've got 400 milliseconds, it's working fine for me, right? It might be working for that specific customer, and it might not work in your use case. So try to stick with 300 milliseconds if you can. So what if you don't have that? What if you have more than 300 milliseconds? What are the things we can do? Let's talk about that. So there are a couple of designs that you can do. For example, you can pretty much deploy a separate ICE deployment. Some of the customers do that. For example, one ICE deployment covering half of the world and other ICE deployment covering the rest of the world, right? So in this case, you won't ever get over 300 milliseconds anytime. You'll stay within that limits. That's option one. Another option would be you can have all the PSNs centralized. Because remember, the flow is between the PSN and the PAN and the MNT. So if your PSN are centralized and you have a data center on both sides of the world, then that should be fine. You're not going to go over 300 milliseconds. That's one other way to deploy. Actually, our Cisco IT is using this model, and they have centralized all the PSNs somewhere in Europe. Yes?
Then what is the restriction in terms of bandwidth PSN?
I'm sorry, say that again?
What is the requirement bandwidth PSN?
Okay. So the question is, excellent. Yes, I've centralized my PSNs, but I've got my switch talking to these PSN, right? Is there a requirement over there? There's not real requirement over there, as we just work with the radius protocol timings. And as long as the radius protocol is successfully working, that's pretty much it. Because from the switch to PSN, it's all radius, or it's some profiling data. That's why it should be fine, right? Okay. There could be one more deployment mode. For example, you can have these PSN centralized, and you can have all these switches talking to your PSN. So to extend your point, what if this link goes down because everything is centralized? So there could be options that you can either use the fallback mechanism on the network access devices, the critical VLAN, all that stuff, or you could have a fully running node of ICE placed, which is just placed over there. In event of this failure, these nodes can go talk to this ICE if you want to. That's one other option you can deploy with ICE. All right, bandwidth calculator. Anybody use this in past, bandwidth calculator? All right, good. So it is a pretty good tool. It can give you a lot of numbers. So a few things I want to discuss here is, for example, if you want to send profiling to the same node or multiple node, and we have a lot of content over that. So we'll talk about that, right? But let's talk about a few things. For example, total number of active endpoints. What does that provide me, right? It gives you the authentication rate on the network. Pretty much how many users are authenticating. Based on that, you can decide the logs and stuff like that, right? Let me ask you another one. How about the re-authentication interval? What does that impact? Any idea? I'm sorry, say again? Which node?
Not a peak load, but average load.
Average load? Yeah, I mean, you're there, that's close. But eventually, it's the logging. The more authentication you have, the more logging you're going to get on the network, right? So I want to give you a Thunderbolt Apple cable. There you go. By the way, that's all brand new, but it's beaten up because of my travels. But yeah, all new stuff. One more thing is the DHCP lease time period. Any idea what that does? Exactly, affects profiling. So think about this. The more DHCP leases you're doing, thank you, it's gonna generate more profiling data, right? So if you decrease your DHCP time from 12 to 2, you're pretty much cutting it down to 6. So that's creating a lot of data, right? So in ICE, when we go to these real deployments, there are two things that really affect an ICE deployment. Basically, all the replication, the logs and everything. And the second thing is profiling. So we're going to talk about all of that stuff. How can we optimize all those things within ICE? All right, so we're done with one. Let's go to the second one, scaling ICE services. So first of all, the basic rule is that once you install ICE and you see all these different services, just don't turn all these services on if you're not using them. For example, if you're not using passive ID, or if you're not using SXP, just you don't have to turn them on, right? Anything you turn on, what it does in the background is that it starts creating these containers and start taking resources from ICE. So as long as you're not using these services, a general rule is that just leave them off. Right? Next thing would be, let's talk about radius TACACs. The best recommendation method is pretty much using a load balancer, because load balancer can do a lot of operational stuff as well. Think about if you have 1,000 switches, and all those switches are talking to multiple PSNs, and if you decide to make a change, or you decide to add one more PSN to the network, right? You have to go to all these network devices, switches, controllers, and you have to reprogram all those settings, right? But if you're running a load balancer with virtual IP, you can still leave everything on that virtual IP, and then all the traffic goes through that virtual IP, right? So again, load balancer can save you a lot of operational work. It can do some additional stuff as well in terms of profiling instead of finding the right node, and we're going to talk all about that as well, right? One example is the ICE authentication policy. So what we see in the field is that, yes, there's a way to configure ICE policies. You get access to tons and tons of attributes. Yes, sir?
Are the load balancing not aware? So if we do load balancing with NAT?
Load balancing with NAT. I have a couple of slides on that, so we'll go over that. But the short answer is that you might run into issues with COA, and we'll talk about how can you figure that out. Absolutely. Good question. So this is one policy example, and you can see that it's not really starting with the right elements. It's not doing the least match first with the most match later and stuff like that. So just to redefine this policy, if you put a policy like this, for example, start with the location, then go into the EPTLS protocol, then go into more policy stuff, and that gives you a really neat policy, and you can start creating blocks. So the idea is that if you have 500 rules of policy inside your ICE deployment, there's a chance you can optimize that with the way you write policies, right? Now, there are a few other things you can do. For example, with all these attributes, you can start creating containers, and you can start creating boxes, and I'll go over some of that as well. Next thing would be the scaling on ICE policies. Pretty much the max policy set you can get is 200. And then the max rules you can get is 1,000 rules. But if you're, in my recommendation, if you're anywhere beyond 100 or 150 or 200 rules, you might need to think about optimizing those policies, because that can give you better performance, and also it's easy to manage those policies. So we'll talk about that, right? Anybody has more than 100 rules in ICE? Oh, nice. You're brave, man. Good. Okay. So what are things we can do to optimize that? Pretty much you can use these conditions, and you can start clubbing tests. For example, in this case, I'm doing LDAP department 1. So instead of going to a specific group inside the LDAP and pulling those attributes and calling them out, I'm creating containers. And these containers could be more dynamic, right? So think about that. Use these dynamic variable substitutions within ICE, and you can have these rule sets really nailed down. So in this case, if I have 5 departments, I can pretty much manage it with one rule, because it's dynamically inserting these attributes, right? So that's one way to optimize policy. Yeah, that's how you do it. You go under advanced setting, and you can just go to internal endpoint policy group, and that gives you something over there. Next thing would be EPTLS. So if you look at these EPTLS performance numbers, they're like 3 or 4 times higher than the normal radius numbers. Typically, a radius number that we'll get would be 250 transactions per second, but these are really, really high numbers, right? And when I looked at that, there were a few things called SR and FR. So session resume and fast reconnect, right? Now what that does is that if you have these settings turned on, pretty much it kind of skips this inner protocol check. So next time when an authentication comes in for the endpoint that was authenticated previously, we're going to skip that internal method and just get you in much, much faster, right? So again, this is like if you're getting out of this door and you just walked in a couple of seconds ago, you might say, yeah, you can get in because I remember your face, right? But if you come back after 10 minutes, that might be a different story. So that's the whole point here, is that if you are known in the system, we can let you in much faster, and you can get much more performance number. Yes, sir?
Yeah, we have a problem with EPTLS. We're getting a message saying the we're having a problem with the TLS, and ICE is basically saying that the client already has a session and is trying to re-authenticate and drops the packet.
Okay.
So is that related to this? Or do we change the defaults? Is that the default setting?
So this is not the default setting, so I doubt if you have enabled that, but what you're getting is something else. It might be how you're distributing the packets into different PSNs, because what could happen is that if your client is sending requests multiple times without waiting for the first request to come on, like, for example, I'm going to do a handshake, I'm going to say hello, and before you're going to respond, say hello, right? So in those scenarios, you start getting those kind of messages. So we can definitely optimize that.
Yeah, actually, we're looking at the logs, and we see it comes up almost 80% completion, and then boom.
Yep.
And it's kind of, there's like a synchronization problem or something, but it's just the timing is not there.
Exactly, exactly. So I'm not specifically covering that, but that's something we can really address. So maybe after the session, I'll talk to you. So that's what it does. Now, what we did in 2.2 is that before 2.2, if you enable the fast reconnect, it only works if you're coming back to the same PSN. For example, I have 5 PSNs, and I authenticated on PSN 1. And if I can only get in if I re-authenticate on that PSN 1 again, right? So that's not a cool use case. So what we did added in 2.2 and later is that you can come to any PSN, and as long as you're within those timelines, you're going to be authenticated, right? So it's more like a golden ticket. I have the ticket, and I can come on any PSN. I will be authenticated on the network, right? All right. So a few things I want to talk about AD is that typically, if you have multiple PSNs and you have a big Active Directory deployment, try to use the sites and services within the AD. And what that offers is that your PSN will always talk to the closest AD node in your network. So you don't want your PSN in Europe to go talk to the AD instance in US somewhere, right, when you have a local instance. So try to use the sites and services within Microsoft, and that gives you this option, right? So that's how you configure it. Pretty much if you go under Microsoft, you can select the sites and subnets, and based on that, you will be routed to the closest AD, right? One last thing I'll talk about is that before ISE 2.4, if you were having failed authentication with the AD instance, that will be blacklisted, right? So you won't have the opportunity to talk to that AD again. So we have changed that. We now have like a scoring system, kind of like a route metric, and depending on how many ADs authentication were successful or unsuccessful, based on that, we give these ADs some score numbers. And depending on those score number, we can just put them back in the game. So let's say if your authentication failed on an AD, and the moment the score comes back up because it's authenticating other users, then that will be added back to the list. So one thing I want you guys to remember is that before 2.4, the AD could be blacklisted, and ISE will not send authentication to that AD, but that's fixed in 2.4, or it's enhanced in 2.4, where now you have the scoring system like a route metric, and that can be back into the game as well. On the LDAP side, there's some enhancements. For example, you can specify per PSN LDAP instance. It used to be a global setting that under ISE you define this is my LDAP server, and then all the PSNs will go talk to that LDAP, right? So now you can define LDAP instances or LDAP servers by the PSN. If you have PSN in somewhere in Paris, you can say just talk to the LDAP instances that are sitting in Paris, right? So that could all be configured. Again, I don't want you to remember all the slides, but if you hear me now, you probably have the chance to go back and look at this instance. Oh yeah, we talked about that when doing these deployments. It's a good set. All right, on the LDAP side, one thing that we added is that LDAP was also blacklisted if the authentication was not going through, but now you can load balance the LDAP, and you can do a force reconnect after every 15 minutes. So instead of just saying, hey, I connected to this LDAP in the morning, I'm just going to send blind requests to this LDAP all day, now you can do load balancing. For example, you connected to this LDAP 1 hour ago, and to distribute load, I'm going to reconnect you in 15 minutes, and obviously your load balancer will send you to the second LDAP, and that will give you the load balancing between the LDAP servers as well, right? So in the last slide, we talked about blacklisting and how we fix that. In this slide, we're talking about if I have 3 LDAP servers, can I load balance between these servers? You absolutely can, because we have this mechanism where I can force you to reconnect every 15 minutes or whatever time you want to configure that. Okay, passive ID, there's nothing much to talk about here, but pretty much we can send services to PSN nodes dedicated for WMI. Is anybody using passive ID here with ICE? Okay, 1, yeah. So definitely, if you are using passive ID, basically what passive ID does is that it can check with Microsoft through WMI if a user is authenticated, and based on that authentication, I can give you access. So I'm going to give you access on the network using MAB, but after that, if I receive more identification from Microsoft AD server, based on that ID, I can flip your access to a contractor or to an employee. So it just gives you more room over there to work with, right? Okay, so I do want to talk about Anycast, right? So I'm going to pick some volunteers here, and we'll talk about how Anycast works, right? So let's say my IP address over here is, I have 3 load balancers, and if you look at, they all have the same IP address, right? And you might say, hey, that might be a typo, but not. So with Anycast, what you can do is that you can have multiple destinations with the same IP address, and it uses the route metric to figure out the closest node, right? Now, this is very, very powerful. In terms of configuration on the network side, on the switch side, on the wireless controller side, you always put one IP address, which is like, in this case, 10.1.0.100. Now, depending where the network's device is, it always picks the closest node. So check this out. For the guest use case, if I have a sponsor portal running, and I'm giving this IP address to my sponsor portal through my DNS, then I can always go back to the same IP from anywhere in the world. Depending whichever PSN node is closest, it will route me to that PSN, and I can get into my sponsor portal. Right? So this will be covered into a lot more sections. Any questions over here? I'm happy to answer that. Okay, so pretty much, yeah, with Anycast, it's just like a routing protocol. You can have multiple servers with same IP address, and it always goes to the closest destination. We recommend using it for portals, for example, sponsor portal, or my devices portal, or posture portal where you're downloading some supplicant, and you can always stick to the same IP address and go from there. Another scaling thing you can do with guest is something called allow guests to bypass the guest portal, right? So in this case, what we're doing is that you can authenticate these guest users by using .1x. The only catch over here is that all the guest accounts should be pre-activated. All the guest users should be already activated within ISE, and your guest users can come in, you give them the username and password, and they can simply go in through .1x, right? What is the benefit I'm getting here? So if I go through the guest flow, if I get redirected, the performance is much slower. All the users have to go to the guest page, enter the credentials, and then log in, right? Over here, I'm giving you .1x performance for all my guest users, right? If you're sharing these passwords. So again, very powerful. If you're trying to scale guest authentication, that's one way to scale all the guest authentications. Okay. One other thing is scaling WebAuth. So one feature we have within guest is the Remember Me feature, right? So if you ever use, let's say you use your phone and you go to a guest network, and your iPhone is connected on the network, everything is fine. But when the phone goes to sleep and you wake it up again, you go through the authentication again, right? So if that happens to you, you can fix it up by remembering these guest users. So instead of going back to the same page, authenticating again and again, you can simply just open the page, and ICE would remember that MAC address in a group, and based on that MAC address, we can just get you into the network as soon as we can. Okay. All right. Any questions before I get into more stuff?
.1x, yes. Doesn't it reduce the false authentications later? So basically, it remembers the credentials, and then at a later point, it will be.
I got the question, yeah. Sure. So I'll repeat the question. The question was that, yeah, you talked about 822.1x guest authentication, right? So in that case, what's happening? Is it remembering my guest or not? That's the question.
No, the question is, it will remember the credentials on the supplicant because this is a different way of
Yep.
authentication. Then it will use them,
Good.
even though they're invalidated already, plus in their ESNs, if you know what I mean.
That's a good comment. So what he's pointing out is that the way .1x works is that you have a supplicant and you authenticate using that supplicant. So once you punch in these credentials in the supplicant, it's always there. And you can just use that authentication. So I don't have to really go and remember me, use that feature. I'm actually going through the authentication of the guest devices. The remember me function is basically on the server side, on ISE side. So what it does is that it's more of remembering the MAC address for the guest users if they're not using .1x.
I think you got my question.
Okay.
Is that with the portal, the user has to go through the portal every time. With the .1x,
They don't have to.
the supplicant will remember the credentials on the phone. The moment I enter them, it will remember them, but they invalidate after 8 hours, for example,
Yep.
because this is the guest access. And after that, every single guest user will try to connect automatically because phones remember them,
Right.
and it will be blasting ESNs with invalid authentication attempts, basically.
Okay.
How does it scale if I have like loads of guest users that will try to
Okay. Sure. So I'll repeat the question, right? So a very good question he's saying is that, yes, I went with .1x and my phone or my devices, they will remember those credentials, right? Now with .1x, what happens is that there's a re-authentication interval, or through ISE, we can set up the guest re-authentication. So once that re-authentication interval comes in, all my devices will try to re-authenticate on the network. And that will be a lot of traffic. If I have 1,000 guest users, they'll all try to authenticate at the same time on the network, right? So pretty much in that case, the numbers we provide, they hold right. Let's say that you're running a standalone deployment with 20,000 active sessions. We will support 20,000 user authentication on the network, right? If it goes beyond 20,000, then you think about scaling ISE. And that is where we get into taking PSN nodes out of the standard deployment and start putting load balancers. So I'm going to go through that into more details, that once you put load balancer, how you can distribute services. Okay? Hopefully I got that right. Okay. If not, I'm going to talk to you after the session. Yes, I'll take one more.
A question about allow guest to bypass guest portal flag. In my case, I had to enable it in order to make guest user work through legacy local web authentication on the VLC. Is that correct? Without that flag, guest user defined on ISE weren't able to authenticate using legacy local web authentication.
I think I didn't get your use case right, but you're saying is that you're using the legacy portal or WLC, so your portal is running on the controller,
And
local web auth.
And guest user defined on ISE weren't able to authenticate until I checked the
Okay.
allow.
All right. That's not the use case it's solving, but I'll talk to you after that. Yeah. What you did is that you did the activated guest part, because with LWA, you cannot really run on the portal and you cannot activate guests. So we'll talk about that. Yeah. Good question. All right. So let's get going. I'm going to talk about some more scaling stuff. So we've talked about how can we scale AD, passive ID, guest authentication. We're going to cover 3 more things. For example, compliance and services, TACACs, and then we're going to profiling, right? And that's where it gets interesting, because profiling is the main thing that can really melt an ISE network. And we'll talk about how can we optimize the profiling thing as we go along, right? So pretty much in posture, the way to scale or optimize posture is to use posture lease, right? This is along the lines what this gentleman asked the question is that I'm getting a lot of re-authentication, right? So in this case, if the users are connecting to the network and you're doing posture every time on that user, it's a bad user experience. So depending on what's the security you're looking for, but with this feature, what you can do is that, hey, you came in the morning, you connected a device on the network, I'll go through posture, make sure the device is good and it's all up and running, and for the rest of the day, you don't have to go through the posture again, right? So that's what it does. Posture lease can give you a lease for that information. Now, one thing I recommend to my customers is that there's something called passive reassessment, that you can tell ISE to go posture in endpoint after every number of hours, 4 hour, 2 hour, 1 hour, anything you like. So with posture leads, you're not running them through the rigor of posture every time when they connect the network, but ISE can still go to these endpoints every hour and check the posture of those users. And if the posture is not right, then I can change the access, right? So that is a very, very good user experience for these users that's connected to the network. So use posture leads with PRA, and that gives you the best performance that you can with posture. MDM. So with MDM, the biggest thing we had initially was, hey, how do I check if my MDM server is live or dead? So we've added these attributes called reachable and unreachable, and you can define policies. For example, if the MDM server is unreachable, the users are not just stuck. They don't have the ability to get a network. But you can define that if the MDM server is unreachable, they can get some basic access. For example, give them internet access, right? Let them on the network so they can open a case or do something like that. So use this flag with MDM, highly recommend it for MDM survivability. A few things we added with MDM is all these new APIs that came in 2.4, right? So what's been happening in past is that, let's say you have number of users in the MDM server which are all registered, which are all good. The moment you connect ISE to this MDM server, ISE doesn't know about the status of these endpoints. So every time these endpoints connect with ISE, it puts them into a bucket, goes to the MDM server, check the status, and then give the access, right? Again, bad user experience. So what we did is that in 2.4, we're giving you these APIs, and you can pre-populate all these attributes through the MDM server. So the moment you connect ISE to an MDM server, with these APIs, you can update the status of all the endpoints within ISE. Hey, endpoint A, MDM server is good. Endpoint B, MDM server is not good. It's non-compliant. And based on that, the user experience is really good. It only affects the non-compliant endpoints, and all the compliant endpoints should be okay to be on the network. Yes, sir. So the question is ISE compatible with Microsoft Intune? Yes, it works. We support Microsoft Intune. Yep. All right, let's talk about TACACS. Nothing fancy in TACACS. Pretty much, when you define these PSNs, you can run PSN as a TACACS, as a PSN, radius node, or both, right? I'm not going to talk much about licensing, but what got changed in licensing in ISE is that now you cannot, you have to pay for a TACACS node. It used to be that if you have 50 PSNs and you have the right TACACS license, just one license, you can run that license on 50 nodes. That's changed now. You have to get a license for every PSN node that you want to run TACACS service on, right? But literally, we looked at our customers, nobody's running TACACS on more than 2 PSNs. So that's what we support. If you had the TACACS license before ISE 2.4, that goes over, and you can run TACACS on all the nodes that support it. So we'll do that. That's an honor system. A few things I want to point out is there. You can have, for example, in a hybrid deployment where you can have maximum of 5 PSNs, you can have 3 running as radius and 2 running as TACACS. So that is all supported. It's called a split deployment, right? And again, the load is by the PSN, and we talked about that. So there are multiple ways you can go and deploy PSNs. But if you're running a TACACS as a dedicated node, then the numbers are pretty high. For example, look at this TPS, total transactions per second. In a fully distributed, like when the PSN and the TACACS node are separated, you can get 2,000 TPS, right? Over here, I was telling you 250 TPS when it's combined. So when PSN and TACACS is running on the same node, the numbers are obviously lower. But if they're running on separate nodes, you get a lot more numbers, right? So, but let's talk about TPS. What is TPS? Pretty much, there are 2 ways people use TACACS. There's a thing where admin can log into the switches and they can configure switches. That's called human admin, right? But in some cases, people will write scripts. And through scripts, they will go into all these devices and they'll just manage these devices all the time, right? So if you're going with the human admin numbers, we don't see a lot of numbers. For example, 50 human admin will generate less than 1 TPS average. TPS is transactions per second. So if I have 50 network admin managing all these infrastructure switches, We don't see more than 1 TPS per second, right? At the same time, if it's a machine, then the TPS goes pretty high, right? This is a good reference slide if you look at that. For example, over here, this is called human admin, and look at the TPS numbers. They're pretty low, like less than 1 over here. But as we start going towards machine, the numbers start getting high. So in this case, the TPS is like, you know, the logs and everything goes pretty high with machine admin, right? So right here with machine admin, now we're talking about maybe a TPS of 32, and it's generating so much more log, right? So what's the recommendation here? The summary is, if you're using scripts to manage TechX devices, it's a good idea to separate TechX nodes and PSN. But if you're just using human admins to manage these devices, you can leave them on the same node because the TPS numbers are very low, right? Okay. Again, within TechX, there's something called single connect node, and it is supported by Cisco devices, legacy device, all that stuff. What that does is that it kind of leaves this session so you don't have to do a TCP connection for every command or every time you connect in, right? And that can also give you some better performance on TechX. All right, profiling. So this is where we kind of spend a lot more time because profiling is a big topic, and I really want to go thorough on this subject. So a few things. First of all, there's something called a certainty factor, and I get this question all the time, right? Certainty factor within ISE is something that defines the type of device. So in this case, I've got 4 conditions. All the conditions have this factor as 10. Whichever condition meets, because the maximum is 10, I'll profile this device as a Microsoft workstation. Yep, very simple example, profiling basics. So the question that I get is that, let's say I have a Cisco provided profile, and the certainty factor of that profile is 30. I'm going to create a custom profile for the same endpoint, same exact rules, right? And the certainty factor is 40 over there. Which profile will take precedence? 40? Yes, you're right. Because it's always a certainty factor. So in this case, the CF40 will take precedence because it's higher, right? Another example, I have this custom profile, which is CF40. Now I go to my feed services, and I'm going to download the latest new profile that Cisco released. So you had an iPad profile, but now Cisco has a new iPad profile, right? What happens if that certainty factor is 30? Which one takes precedence? 40, exactly. So it's always certainty factor. So this is a trick that I tell a lot of my customers, that if you have a custom profile that you absolutely love and you want to keep it, even if the box is connected to feed services, make the certainty factor of that profile to a higher number. So no matter what Cisco pushes, whatever you're feeding in, that profile will always take precedence. I'll repeat it, go ahead.
Okay, I don't agree with it. It really depends on the attributes you're checking. You have to make sure they are really unique, and also the parent profile will be different. Because you run in a situation, it's all timely based on when the accounting frames arrive. Yep. There's a great chance you will match the profile with certainty score of 30 before you match the 41. Yep. And when you have a default action configured, like a port bounce or re-authentication, which will lead to change of VLAN or stuff like that, yep, you will have a constantly rebooting IP phone maybe.
You're right on that. I mean, so there's multiple factors. So the whole point is condition. Remember I talked about these conditions? And you pointed that out, that it's like a firewall rule. If I'm meeting those conditions earlier, then I'm going to match that profile. You're absolutely right, right? But I was just trying to give an example that if you have the same profile, for example, you took the iPad profile you had that came with the box, you customize it, right? And you want to keep that iPad profile. So the one trick to keep it is to manage the certainty factor. Right? So I'll go over more of those use cases. Yep. Good. I'm loving it. I've got good experts here. Amazing. All right, so we'll go through a few other things. Why is it going in the opposite direction? Oops. Okay. Next thing I'll talk about is the attribute filter. So within ISE, we collect a lot of things from the device, tons and tons of information. So if I show you, for example, what do we collect, these are all the attributes we have for the endpoint, and it might be more, right? So the thing is that, do I really want to remember all these attributes and keep syncing up these attributes all the time? For example, if PSN notices one of the attributes of this device has changed, is that attribute significant enough? So I have to go back to the mothership and update it, right? And imagine if I do it all the endpoints, for all the endpoints, it can cause so much traffic on the network. There'd be so much database synchronization going on all the time. So what we ended up doing is that we defined something called an attribute filter list. What that does is that it picks the attribute that really makes sense, right? So in this example, we have all these whitelist attributes. And if you look at these attributes, they are related to most of the stuff that can change. For example, the MAC address. If the MAC address of the endpoint changes, yes, I have to go tell my mothership that something is bad happened, right? And then we have something called significant attributes. So the idea is that if any of these attributes for an endpoint change, the PSN will go back to the PAN node and update it, because that is absolutely important, right? But if the attributes in the whitelist changes, then I can pretty much manage it within my PSN node group. We'll talk about what is a node group. But if you have a set of 3 PSNs on a site, and these attributes are changing on one of those PSNs, it's fine. They can replicate between themselves and update these attributes, but I don't want to go back to the mothership yet, right? So just keep that in mind, and I'll give you some examples of how this works. Yeah, again, this triggers a group update within the PSN node, and this triggers a global update across ISE, right? And it's very important to understand that these are very significant, and if you have thousands and thousands of endpoints, this replication can cause a lot of churn on the network. So we'll go over how this works. So let's talk about what is a PSN group. So as we said, all the PSNs and everything will be going back and reporting to PAN, right? If we create a node group, that is like a node group between the PSNs. And these PSNs can communicate between themselves, and they can exchange whitelit attributes all day, which is okay, right? One other benefit of a node group is that, for example, you have 3 PSNs, and this PSN had 20 endpoints, right, on the network. And the PSN goes down, right? What happens to those 20 endpoints? They'll be stuck in a state, because nobody will go and re-authenticate their endpoint unless the user does a Control-Alt-Delete, or they take out the cable and put it back again. So the benefit of using a node group is that all these PSNs, they have a heartbeat between them. And if they notice that one of the PSN is down, the next PSN that is available takes up all the session that the PSN had and just try to re-authenticate all those endpoints so they can come back on the network, right? So from a survivability perspective, node group is definitely something you want to figure out and have in your network. So let's take an example. If I'm changing the DHCP attribute on this PSN, for example, an endpoint authenticates request for an IP address with the DHCP server, we will send the same copy to the PSN for profiling purposes, right? So this, my PSN gets the attribute. What it does is that it says, hey, I am the owner. It takes the ownership. But if the next DHCP update for the endpoint goes to PSN2, that PSN will take the ownership. And it'll say, hey, now I'm the owner. But so it has to go and update the endpoints. In that case, it can simply go to the node group and just update the endpoints, because it's not a significant change, right? But if it's something that is global, then absolutely the PSN2 has to go out and update the whole deployment about this replication, right? Okay. So yeah, if you have multiple node groups, the local updates will be within the node groups. And if it's a significant update, it has to go across the PSN and update the PSN accordingly, right? Okay. So I do want to talk about this slide. Pretty much what's going on here is that it's just an example. A user is connecting on a Wi-Fi wireless network with an iPad. The request comes into this PSN, and then it gets redirected to this web portal, right? After that, if the PSN goes down and you're in the node group, the next PSN can take over all the sessions and re-authenticate this endpoint and then the endpoint can go back to the next PSN. So that is a huge advantage of using a node group within a site or within a deployment, because it's giving you survivability on the network. All right, so if you haven't seen this before, this talks about all the ports that are used between the ISE deployments. So if you have a firewall team, or if you have servers between, you're doing some filtering, it's a good slide as a reference slide that you can take a look at to go with the endpoint. All right, this is one of my favorite slides. So what's happening here is that we'll talk about the problems profiling can bring to your network if it's not properly tuned, right? So let's take one step at a time. For example, I have all these devices, and these devices will connect on the network, and depending on how the profiling is configured, I will start getting data on the ISE nodes, right? So what happens when the device connects on the network for the first time? I'm going to go through a radius authentication, and as you can see, the device came with the access point to the switch, and it went to PSN number 3. Now over here, PSN 3 said, hey, I am the owner of this device. If anything changes, I will go update everybody, but I am the owner of this device, right? Whenever there's an ownership claim, it goes and updates everybody. So basically, this PSN went, updated the PAN, and then PAN went and updated the whole deployment, that PSN 3 is owner of this endpoint. Now, since this is not properly tuned, the endpoint now comes in and tries to do a DHCP request. And in this case, we're sending this DHCP request to PSN 4 and PSN 7, right? Now, what does a DHCP request do? It's a MAC address change. So if the MAC address is significant, these PSNs will say, I am the new owner of this endpoint. And whenever there's a new owner, there's always a global replication, right? So what we did is that we sent it to the wrong PSN, and because of that, there's a global replication that started happening for all the ISE deployment, right? So there you go, issue number 2. Now what happens is that this PSN tries to do an Nmap query because it's configured by the profiling, go run the endpoint and the endpoint. So it sends that request to the Nmap, but the result when it comes back, radius accounting, it goes to PSN number 2. Again, significant update. Now what I'm doing is that, hey, PSN number 2 says, I'm the new owner of the endpoint, and I'm going to go tell everybody that I'm the new owner. A lot of update that goes in the network, right? Similarly, a few more examples that if the Nmap is still running, that can also trigger a global update. If there's a PX script update and there's significant attribute changes, there will be another global update, right? So you can see that we're sending so much of unnecessary traffic across the network, and we're just updating the entire deployment with this traffic, right? How can we avoid this? Let's see that if we tune the network right, by the way, this is when it's not tuned, that's why you're just getting all these ownership changes, and you're getting replication, replication, replication. This is before tuning, right? What can be done is that if this is tuned right, you can have this switch send radius request to PSN 3, and also the DHCP request goes to the same PSN. All the Nmap things goes to the same PSN, right? So if the traffic keeps going on the same PSN, you don't get that much update of this endpoint across the network with a global deployment, right? So the goal over here is that once you're authenticated to a PSN, try to send all the other traffic to the same PSN, and that can stop a lot of replication that could happen on the network, right? So we'll talk about that, how that could be done with the load balancer, without load balancer, and we'll take all those details. Any questions here? Yes, sir.
Let's say user is in Europe and using a PSN in Europe. Now this user deployed in Asia for 2 weeks to do some work. What happens then? Which PSN is he authenticating?
Okay, so the question is that the user is in Europe and authenticates with the PSN in Europe, right? So that will be the owner of the endpoint. Now you got to make sure that the request just goes to the same PSN for the next time or for other services. It doesn't go to some other PSN that can cause some huge replication database. Yeah, so we'll talk about that. All right. So yeah, the point here is that it's just not creating a lot of ownership changes. That's why the overall traffic on the network is really, really down, right?
Device sensor, and it will be one session.
Absolutely. So the question is that, is it better to use device sensor? Yes, device sensor is one of the things you can use, and there are other things you can use as well. I think I do have a slice over here, right here. So the recommendation is that use a device sensor, right? Ensure that profiling goes to the same single PSN that we talked about. You can have maximum of 2 PSNs, and ensure that the profile data is sent to the same PSN, right? So I'm not going to read through all of that, but the things you can remember over here is, do not send profile to multiple PSNs. Do not send data to single or same PSN all the time or to the node group. And yes, do use device sensor and enable the profile attribute filter that we talked about. So it just doesn't replicate everything on the network, just replicates the significant attribute. All right?
If you enable, if you configure the filter for the attributes, how? If you enable the filtering for the attributes, how would you then capture customized unknown devices? So if I need to capture all the attributes and create a custom profile.
Yeah. So the question is that, yeah, you're creating this filter, but I'm capturing more attributes of the endpoint. So the beauty is that you can, the significant attribute today is hard-coded, but pretty much if the endpoint, once the endpoint is going through the profiling process and we're collecting all those attributes, they are replicated. Because remember, whenever there's a new owner, the owner says, I'm the owner, and replicates everywhere, right? After that, only the significant attributes will be replicated, not all the attributes will be replicated. So you will capture that custom attribute. Yeah. All right. So let's talk about profiling redundancy. Pretty much what we're saying is that if you have 2 data center and then you have 2 load balancers, yes, you can start sending them requests. So in this case, the configuration I'm doing here is that I have a VLAN and I'm sending this DSCP helper address command to both of the load balancer, and eventually it'll get to one of the PSN, right? Certainly not the optimal way, because in this case, there could be an ownership change, because if it goes to data center 1 versus data center 2, if the stickiness is not properly configured. But this network device is depending that where it's sending this traffic out. The other thing you can do is, remember we talked about Anycast? So if you have Anycast configured, both of these load balancers have the same IP. In this case, it will be more depictive. For example, this switch will always send it to one load balancer, and then this will not create a lot of churn on the network. Right? That's one way to optimize it. One other thing that we do with profiling is the SNMP probe. Pretty much what SNMP does is that the PSN can go to these switches and learn about the SNMP attribute. So if you have those printers which are not really actively participating on the network for multiple authentications or profiling changes, then in this case you can use this filter to profile at least these kind of devices. The top use case I see with my customer is printers, right? So how do I optimize that? Because I don't want to create a lot of traffic on SNMP as well. So in this case, first of all, we changed the polling interval. It used to be pretty low, but now we think that 28800 is good filter. And then you can also choose which PSN would this switch go to, right? So in this case, this switch right here, 3750, is programmed to go to auto, which means any switch. But it can be changed that, hey, you can just go to like PSN 2, because that's the closest PSN you have, right? So in this case, you can also save a lot of traffic or profiling update on the network, right? So one issue we had that earlier, and it's fixed now, is that if you hard-coded a PSN per switch, and if that PSN goes down, you are stuck, right? But that's fixed now. Pretty much, even if that PSN is down, in 2.4, there's an auto recovery which just gets to another PSN and gets your profiling data in there. PXGrid, that's one of the nodes where we can learn more custom attributes. So for example, you talked about how can I learn all these custom attributes. So in this case, if you have devices which are sitting outside of ISE, for example, you have these IoT devices in the industrial network. I can learn those attributes through PXGrid. That's one use case. So pretty much we can start creating these custom attributes, and we can absorb all of these custom attributes within ISE. So in this case, this is an IoT device. There's no way ISE can go and profile these devices with IoT probes, because we don't have them. It's an IoT thing. But we can work with the IoT controller and get all these attributes within ISE. and then use these attributes for profiling, for device identification and stuff like that. So that's very important, and we're getting a lot of use cases on this one, especially the OT and IT side of things. ISE can go and profile all the IoT devices or the OT devices, and then you can program a policy on the OT firewall to define what happens for the access of these devices. So very, very important. Is there a question? Okay, all good. So yeah, how does this work with PX Grid? You can just go and enable PX Grid Note. It's with 2.4 you can have up to 4 PX Grid Note. We support that, and that is all part of the program. All right. So I think we talked about that. I do want to jump to this section of MNT log suppression. Okay. So we talked about profiling. Profiling can really cause a lot of issues on the network, and we talked about how can we fix it, what are the things we can do. The other thing that can cause a lot of churn on ISE network is the MNT logging. If you're getting excessive amount of logs on the network, that can also be a problem, right? But how do I get these logs? Like, what are the sources? With all these new devices coming on the network, authenticating all the time, and depending on if there's a bug in NAT site, for example, you just said, I'm getting these timeout errors. I need to figure out, is it a device problem, or is it a switch problem, or is it an ISE problem, right? So what we have seen in field is that a lot of time it could be a device issue as well. The device just keeps on sending data without waiting for the response, right? So there are many use cases, we'll go over that. But basically the point over here is that all these new devices, they can cause a lot of churn in the network, a lot of logging in your network. So we'll go over a few things. We'll talk about how can you contain these logs on the switches, how can we contain on the load balancer, the PSN, and then ISE, right? So I'll take you through all of that. So let's get started. Again, this is just an example that it's really a live network. They only had 6,000 endpoints, all BYU devices. It's like a school network where students were allowed to bring in their devices, right? Look at the amount of data we were getting on this network, right? 10 million authentication with 9 million failures in 24 hours. Because all these kids, they have these devices, they pull it out from the device, open the device, and the friend says, hey, you want to play soccer? Yeah, let's go play soccer, right? So pretty much you have these devices when you turn on, it sends an authentication request to ISE, but before ISE could respond, the phone was back in the pocket and he was gone. And it was leaving all these tail sessions, right? So what happens? It just creates a lot of log data, a lot of authentication failures, right? And there's ways that we have fixed that into ISE, and we'll talk about that. So the goal over here is to really reduce these authentication. So I'm going to take you through 3 things. First of all, there's a whole site of switches and load balancers. What are the things you can do on this site to prevent these logging? The second one would be PSN. So when the packets are coming into the PSN, all the logs that are coming in, you only take the logs which make sense. You don't have to absorb all the logs and take into PSN. So we'll talk about all those filters we have within PSN that can stop these logs from coming into to the ISE deployment. And the last thing is MNT. Now we're talking about, this is the monitoring node, and it's going to go and store all the logs that come in. So we need to be careful about what logs should we store. If the endpoint is authenticating 20 times in a minute, is that useful to me? Probably not. I already know that this endpoint is having a problem, right? So we'll talk about how can we contain all of that logging activity within the network. All right, so there are a few things you can do on the network side on the switch. For example, play with these radius numbers, and we have some recommendations that you can do. So Clark has a session in the afternoon, and you really deep dive into all these numbers. That what are the settings you can do on the controller side, on the switch side, and how can you optimize these numbers, right? But typically my customer would say, hey, you already know these numbers. Why are you telling me to go program these numbers? Can you do it for me, right? So absolutely, what we offered in WLC 8.4 and beyond, that there's a button called Apply Cisco ISE Default Settings. The moment you check this mark, it automatically goes and sets all these timings that are needed to work with ISE, right? So if you're running a WLC 8.4 and any version after that, I would highly recommend to use this setting within the wireless LAN controller. Okay, again, this is like a kind of a money slide, talks about these are all the versions we have, what is new, what is mature, what do you need, and all the bugs that are fixed in these versions. So if you're looking at WLC deployment, that's a good slide to pick up the right code for your network. All right, again, on the wired side, same thing. Pretty much, you need to set up these radius probes, and I have all these slides that talk about, but things we care about is that the hold time, the quiet period, the rate limit, and if these are set to 300 plus second, you should be fine, right? And session time is important, and typically we say just disable it or increase to 2+ hours for session time on. All right, let's talk about radius probe on the load balancer. Pretty much once we've set up the right settings on the switches and wireless LAN controller, the next thing is load balancer. And really the trick over here is the heartbeat, right? I mean, we've seen that there are some devices who would just go and look for load balancer all the time. Is my load balancer available? Is my load balancer available, right? And that can create so much traffic on the network. And we've seen some cases where we're getting a lot of logs on ISE that, hey, somebody's just sending these constant logs and trying to find nodes availability. So yeah, heartbeat frequency is very important, and we have recommendation how to set it, but typically we recommend doing 20 to 60 second for this heartbeat interval between NATs and the load balancers. All right, these are some examples that how can you set it. We have an example for Citrix to set up these probes, and F5 example as well for these intervals and timeouts and all that stuff. So if you're using this load balancer, you can definitely take advantage of this slide and just configure the right settings. All right, so we talked about the network devices and the load balancer. Next thing would be PSN. So remember we said we were getting 9 million failed authentication in 24 hours, right? And I already know that, yeah, maybe it's from the same devices. It's not really useful to me. So what we have done is that within the PSN, we have created these log filters. And we give you this option to really, it's up to you, what you want to log, what you don't want to log. And we have some recommendations around it. So I'm going to go through those numbers and see how that works. So pretty much, there's something called attribute filter within ISE. And you can say what needs to be filtered and what gets stored in ISE, right? For example, if you want to disable suppression, yeah, if the endpoint is failing authentication all the time, I already know that endpoint is failing authentication, just don't send the request to me. Just send it every 15 minutes or every 5 minutes or whatever you want to configure, right? So how do I get this done? If I go on this slide, these are all the radius setting within ISE, and these are the numbers that you play with. For example, the first one says suppress repeated failed clients. So if I'm seeing 2 failure attempts from the same endpoint within 5 minutes, right? I can say that, yeah, this endpoint is having issues. I don't want to log it anymore. So if you, in your case, probably if you don't have suppression turned on, you'll just start seeing these endpoints failing again and again on ISE. So I highly recommend you do this suppression filter list. And what this does is that it will still report to ISE after every 15 minutes. So it's not sending active reports all the time, but maybe after every 15 minutes, it'll tell you that the endpoint is having issues. So the next thing would be rejected repeated fail request. So in this case, if the endpoint has already failed rejection 5 times, and this is pretty much hard-coded in ISE 2.0, but now you can change it, it will just reject the endpoint. It won't even send this radius request all the time to the ISE, right? So it's very, very powerful. So make a use of that. The last thing is more on the MNT side. So pretty much what you do on MNT is that you can talk about what are the logs that are useful, what are the logs that could be just thrown away. And if I look at that, we're talking about if somebody is sending successful authentication all the time, your endpoint just keeps on authenticating on the network, and I'm just getting, yeah, the endpoint is successful, right? That's again not useful to me. So I can also suppress these logs. I can say, you know what, I don't have to store all these logs. One other thing that is very useful is the authentication detail, and it gives you a number, and you can program it what is the high number. So if you go to your MNT logs right here, there's something called step latency, and if this number is constantly higher, then you can see that what's happening with this endpoint. Why is the latency so high between the endpoint and the MNT node, right? So, and you can figure that out. So these 2 settings are very useful for MNT. So I'm going to show you a slide that talks about how this works. Yeah, it actually is the next slide. So let's take an example, right? I have an endpoint that comes in, authentication fail, 2 times, third time it fails, I'm going to put you under suppression, right? But ICE will still get the report. Now you're in the bad boy club, right? But your authentication is still failing. After that, if it fails again for 5 times, then we just put you in this bucket and we just send a reject report, and that's it, you're out. After that, we put you into something called suppression bucket, and we don't even look at the endpoint. You can do whatever you want, but it's not talking endpoint, right? So typically what this does is that if this endpoint has a problem all day, it's contained right here. I'm going to work with the endpoint for 7 times or 8 times or 10 times, whatever you configure, and after that, I won't be getting all these reports from the endpoint, right? So imagine this is just one endpoint. What if I have so many endpoints coming on the network? Even these reports could be painful, right? So that's why we recommend playing with these timers and setting the right settings. Any questions on this? All good? Awesome. Yeah, I'm just keeping an eye check on time. I do want to talk about all right. We got 2 more topics, high availability and monitoring, right? And so let's get into this. So first of all, high availability. If you look at high availability, I'm going to take you through all the steps, starting from the hardware to each of the guest services within ISE, right? So let's look at the hardware. First of all, if you're running a 3595, the large appliance, it does come up with dual power supply, so that's fine. 3515 does not come with dual power supply, right? But you can absolutely put a power supply in it. You can buy one and support it, right? But take a note that if you send a box to Cisco for RMA and it has 2 power supplies, you're only going to get 1 back, right? So take the power supply out before you send it to us, right? Yeah, we're not going to keep it. We'll just, throw it away or something. Next thing up is NIC teaming. What this does is that it's not increasing the bandwidth on the network, but it is used for high availability. So ISE comes with pretty much 6 interfaces, and what you can do is that you can say, hey, GE0 and GE1 are part of a NIC teaming. What that means is that they will share the same MAC address and the same IP address. So if one switch goes down, the other switch will automatically pick up the same MAC and IP, and it'll start working. So that's the whole idea of NIC teaming. This is not LAC-P or LAP-C and all that stuff. It's not doing redundancy. It's not increasing your bandwidth, but it's really a high availability thing that we have, right? So these are details. Pretty much, they share the same MAC address. So let's say you have 2 switches and you have these interfaces connected. If this interface goes down, you can absolutely pick this up with the same MAC and just start working with it. So all your services will be up even if one interface goes down. Okay. Right. So how do I configure that? First of all, this is pretty much hard-coded. The numbers that I showed you, you cannot change that NIC team bonding. It has to be the same number, 0, 1, and all that stuff. You can go to the interface and you can configure this backup interface. So for 0, you're teaming up with interface 1, and you go into ISE and configure this command. And after that, you'll see this bond. By the way, once you configure this, you have to restart ISE, right? So once ISE is restarted, you'll see this interface called bond 0 now. So both 0 and 1 is gone, it says bond 0. And then you can select this interface and start using it as an ISE service. All right. So the next topic would be node redundancy. And I'll go over admin, MNT, and PXGrid node, that what happens when the admin node goes down, what happens when the MNT or PXGrid node goes down, and we'll look at that option. So let's start with admin node. Pretty much the way admin works is that if you have an admin node, the admin will log into this primary node and configure the ISE deployment. And in case if this admin node goes down, prior to 1.4, the admin had to go to the secondary node and promote this as a primary node. Like, hey, you're promoted, right? So that's how it used to work. After 1.4, we introduced something called automatic failover. So if the primary node is down, the secondary automatically gets promoted to a primary. And so your services are fine, right? So let's talk about that, how that works. The services that does get impacted is pretty much not a lot of services get impacted. Let's say if you have guest on the network, they're trying to authenticate and the admin node is down, your existing guest authentication works fine, right? But remember this global replication I talked about? Whenever there's a new endpoint that is profiled on the network, what happens? ISE has to go and tell everybody in the network there's a new endpoint, right? And that is done through the PAN node. So if the PAN node is down, your new guest users will not be able to authenticate because the replication won't complete. That's the reason, right? Similarly, so a lot of services that are running don't get impacted, but things like new BYOD devices getting registered needs to be replicated. That's why it doesn't work. A new MDM device needs to be replicated. That's why it doesn't work. But existing radius, existing users, Active Directory, everything works through the PSN, and you're pretty much okay. So yeah, this is what we introduced after in 1.4, pretty much automatic failover. So what happens is that there will be a third node that checks the status of these servers all the time. And if third node detects that, hey, this primary node is down, it goes and promotes the secondary node automatically, right? And this is the question I get all the time, that for my automatic PAN failover, you don't need 2 nodes, you actually need 3 nodes, right? And it doesn't have to be one node that's just dedicated for this service. You can use a PSN or you can use MNT for that services. One thing that I would say, it does take about 15 to 30 minutes, depending on the network size. In a lab, it could take 5 minutes for the failover to happen, right? And during that failover, if there's any logging or things going on, that are pretty much lost. So that's something you want to take in mind. Yes, that's a question?
Do we need the license for the third node to make this failover happen?
So the question is, yeah, everybody heard the question. Pretty much what I'm recommending is that use one of the nodes you already have. So you can use one of the PSN to monitor the health of these nodes. So you pretty much would have the license for that. But yes, that will be counted as one of the service node.
Hi, how does this translate to standalone deployments?
Okay. So for standalone deployments, if you want the automatic failover, then you're going to have to put another node. You're going to have to put another node. Yep, good question. Good. I'm getting amazing questions, by the way. You guys are expert in ISE. I love it. All right. So how does this work? Pretty much the configuration slide that you put in the primary, you put in the secondary, and then it requires a minimum of 3 nodes with the observer, and then the health check node cannot be the PAN node. So that kind of answers your question that in a standalone, if both have PAN running, that cannot be the monitoring node. Okay, so let's talk about HA for monitoring and troubleshooting, MNT node, right? So the MNT node are both active all the time. They're both receiving logs, but they're like primary and secondary from the perspective of the PAN node. So wherever the PAN node is sending the logs to, that MNT is the active node at that time, right? So in case if the MNT node goes down, yes, you start sending logs to the other MNT, or they're already being sent. But the idea here is that during this failover, which could take about 5 minutes, your logs could be lost, right? And if you really want to save those logs, you can configure something called local logging on the PSN nodes, and those logs will be saved locally on the PSN for that period of time. Now, those logs will not be sucked into MNT automatically when the MNT comes back up, right? So that's why I really tell this is a condition point that, yeah, there could be cases where the log could be lost, but in practical, a lot of our customers are using some external logging servers, or they're pushing data to like Splunk or something like that, and that's how it works. Right? Yes?
So a question about admin non-failover. is this preemptive? So what happened when the failed node came back again?
It's not.
Not preemptive.
So if the primary comes back again, we don't want to put you through the 15, 30-minute outage again. Why?
Okay.
Right? That's why it's there. But if you have a deployment, typically in a deployment, the PAN configuration would match up. But for some reason, if you have the primary running on a hardware and secondary running on a VM, and you prefer hardware, then that is where you want to put it back to the appliance, right? So yeah, you have to go and change it yourself.
And manual promotion means downtime?
15, 30 minutes, depending.
Because the reloads all the
Exactly.
processes.
That's the whole
Okay,
point.
thank you.
Sure. Good question. All right. So that's what I was talking about. There's something called TCP and secure syslog targets. Once you configure that, it'll start storing all those logs locally on the nodes, and you can just use them, right? PX Grid HA, well, nothing much, but before 2.4, we used the client, the PX Grid client could talk to both of the controllers, but one at a time. But now in 2.4, the client can talk to multiple PSNs. So one client is subscribed to two PSNs or PX Grid nodes, so that gives you more high availability on the network for the PX Grid nodes, all right? A few other things I want to touch upon is PSN load balancing, right? So in this case, now what we're talking about is that how can I load balance all these radius, webauth, and profiling services? So absolutely, first thing recommendation is to use load balancer, and through load balancer, you can create stickiness. Once you have the stickiness created, the radius authentication, the profiling data, all the thing can be pinned to the same PSN, and that can save you a lot of churn on the network. So when we talk about scaling all these services, absolutely leverage the load balancer and go through that. I'm going to show you some of the examples of load balancers. For example, if you have multiple PSNs behind a load balancer, first thing you want to do is to create this node group. Remember we talked about this node group? So have these PSNs in one node group and put them behind a load balancer VIP, right? And that's how you create it. That's all configuration slides, so you have the reference. There are multiple ways you can deploy load balancer. So in this case, one way is to deploy a load balancer through a physical separation, right? So pretty much your load balancer is fully in line to the traffic. Any request that comes in from the user, it goes to the load balancer, and the load balancer can start pointing to the PSN that you like. That's one configuration. One other configuration is load balancer with VLAN trunking. So in this case, I have multiple VLANs on this load balancer, and the load balancer is not fully in line, but it goes through the VLAN and the traffic comes in. This is still okay. I mean, I don't see a lot of issues with this. That is still fine, and that works. Now, where we see a lot of challenges is that when people try to create this complex load balancing redirection for something, I mean, look at the amount of hops it had to take just to figure out the right PSN, right? And then once you go on these cap calls, you spend a lot of time in load balancing configuration. So yes, this works partially in line with layer 2 separation. Definitely it works, but it's a very complex thing to set up and configure, and you can run into issues. So my recommendation would be to have a load balancer in line to the traffic, physically separated, or maximum you could do VLAN separation and just deal with that. That is the best thing to do with load balancing. Any questions on load balancing? Yes.
Which are the recommendations about how to configure persistence on load balancers?
Sure. So very good question. We have this full guide that we released with F5 load balancing guide. It talks about step-by-step persistent load balancing. And two issues that I usually get a customer is, for example, fragmentation. So if the load balancer is fragmenting packet and it's not putting the client IP address in the second packet, then it won't get redirected to the same PSN, right? Because you end up doing that. So I would recommend taking a look at this F5 LTM, but if there's specific questions, meet me after the session and we can go through that, right?
Is there a fix for that?
There is a fix. There is a fix. So F5 just fixed it in their code. And then I think Citrix also has a fix, but that's a very common problem that we had. They have a fix for that. Another problem is that if the fragment size, for example, the switch before the load balancer, if it's fragmenting the packet into very smaller chunks, the default configuration of load balancer sees those packets and it thinks it's some kind of malware and it drops the packet. So there's a fix for that as well, and there's a configuration in this guide that talks about how do you deal with those fragmentation packets. There's a setting under F5, and you can take a look at that. Certainly, yeah. All right, so yes, you can have PSNs without load balancer as well, and typically these examples are, let's say, working with the DNS address. So depending on what the resolution is happening, the nearest DNS will resolve the IP address. So in this case, this admin is trying to go to sponsor.company.com. The DNS returns the IP address that is closest to this user, and then based on that, it can redirect the traffic over there. Similarly, if the admin is coming from another location with the same FQDN name, he gets a different IP address, right? Because the DNS returns the closest IP and then goes over there. That's one way to load balance services without a load balancer. Again, Anycast configuration is another way. If you don't have load balancer, you can work with Anycast and it can give you some kind of load balancing. And that's how you configure it. Pretty much on the PSN, you're just putting the same IP addresses. And this cannot be a gig 0 interface. Often people try to change this IP address on a gig 0 interface and they run into problem because gig 0 is the admin interface. If you have two PSN with the same admin IP, it's not going to work. Right? That's why I use the gig 1 interface or gig 2 or some other interface than gig 0 and configure that with Anycast address. And then I think we have a slide that talks about the switch configuration. On the switch, how would you configure and set up these metrics and all that stuff. So that's all available for you guys. Right? One other thing is the NAT-based radius redundancy. So pretty much in the switches, you can configure up to 3 AAA servers. And based on that, it kind of sends this request to these PSN servers. Again, it's a use case. If it's a simple radius, this works fine because it can send batches of data to one PSN and another batch to the second PSN. But once it starts getting into profiling and guest use cases and redirection, that is where you can experience some issues and you might want to jump onto the load balancing. The last thing is, IO-based redundancy, we talked about that, but this is the command that does the magic. The load balance method least outstanding, and you can configure the batch size of the amount of requests that goes to the first PSN, second PSN, third, and comes back to the first one. So you can configure the batching over there. Right? Okay. A few other things I want to touch upon is pretty much how are you distributing these loads. So in this case, you can see that I turn on this distribution to 3 PSNs, and I'm fairly seeing 1, 2, 3, 1, 2, 3, and the load is being distributed. So if you go under ISE, look at the server, and the server will tell you how this load is being distributed across these PSNs. If you don't have endpoints, you just want to test in the lab, you can always run this test AAA command, and it starts sending this traffic towards this PSN. All right, WLC. So in WLC, the way this works is that it has 3 modes. So let's say if the WLC is trying to reach to ISE PSN and it cannot reach, so it marks that PSN as dead and it's always dead, right? And that mode is called off mode, right? The second mode is passive. In passive, what happens is that let's say if the PSN was not available at that time, it's going to mark it as dead, but after so many seconds or minutes, it'll try to go back to that PSN. So just start putting that PSN back in for authentication. If it works, it works. If it doesn't, it still fails, right? Which is, again, not the optimal method. I like this active method. What active does is that if the PSN is down, the WLC will go on the side and always check for the heartbeat with the PSN. Hey, are you ready? Are you ready? And only brings back that PSN back into your authentication if the PSN is now back live and it's running. So yeah, my recommendation would be the active mode to use for WLC load balancing without a load balancer. All right? So I do want to jump on my last topic, which is monitoring, because these are all the reference slides that you can use. All right. So let's talk about that. There are a few things you can do. Within ISE, if you go to the dashboard, there's a lot of data available. It can tell you all the latency, the time of authentication. That's something useful I recommend to a lot of customers. You can always see the CPU usage, the memory, and authentication latency on ISE, right? So again, if the latency is going high for a few seconds and comes back in, it should not be a problem. One of the alarm that I see is that, has anybody seen that alarm called your VM resources are running low? Right, you might see that, right? Again, if it comes occasionally, that shouldn't be a problem. Because occasionally, at that point in time, when it was checking the VM, it was crossing that threshold mark, right? So that is fine. But if it comes more often, then certainly we'll go and take an action on that one. A few other things you can do is server health. So pretty much you can look at the operation report, diagnostic health. Health summary is a good one. It tells you overall function of ISE. That's a good page to look at. You can look at the endpoint capacity of all the nodes. What is the load on each PSN? And I absolutely love this. This is a good thing to look at. It was introduced in 2.2, right? Last thing I want to talk about is pretty much these profiling statistics. So if you go under ISE with application config, you can run this command, display profiling statistics, right? And it gives you all these statistics of profiling that's going on. And it can give you an idea of the amount of churn that profiling is causing on the network. So that's one good thing to look at as well. Last thing I want to point out is pretty much the endpoint ownership change. We talked about the endpoint or the platform that's been changing, right? So you have a report on this one, and you can log into ISE and look at these customer attributes, and it can tell you, hey, this is detected as a large platform, and what is the endpoint ownership on that platform, right? So again, something good to look at, right? So I think I did cover most of the things that I wanted to cover today. Just housekeeping stuff. What are the key takeaways? We talked about 4 things mainly. We talked about ISE design. We talked about scaling ISE. We talked about high availability. And we talked about some of the monitoring stuff you can do with ISE, and you can take advantage of that, right? I would recommend, again, to look at this community link, which is very, very useful. It has a lot of information. Whatever was presented today, we typically go and update all these websites. So all the scaling numbers, anything that is available, are available there. So between now and in our next session, if we put new ISE release or we put out new platforms, we'll absolutely go and update all these sites with these new numbers. So very super helpful to look at these community links. Performance scale, there's a whole document, take a look at that. Please complete your survey, that is very important to us. The whole point of this session is to really deliver the content that you like. Yes, I would appreciate if you can take some time and give me a feedback on the survey, and also talk about what are the things that we're looking for, what are the things that were covered, or what are the topics that you would like to cover next time as you go along, right? And with that said, there are a number of things you can do after this session. Meet the engineers, I'm available over there, schedule a meeting with me. I had some interesting use cases, I would like to hear more about them. So yeah, I'm available here till tomorrow, and happy to be in a one-on-one meeting at the Meet the Engineer or anywhere you like, and we can talk about your use case as we go along. With that, thank you for coming. Hope this was useful. And again, thanks for coming.